So in this one, we're going to look at simplifying radical expressions. And a radical expressions means that we're taking a root of a number. It doesn't always have to be a square root. We can take any root, a cube root, a fourth root, a fifth root. If there is no number there, remember that means it's a square root or there's a 2 there. Okay, so square numbers are obtained by multiplying a number by itself. So a square root of a number is the number that was multiplied by itself. So I know that sounds like a little bit of a riddle. I'll show you what I mean in just a moment. If the number is not a perfect square, then it can be broken into factors so that some may have square roots taken on part of the number, okay? So if we have a number times itself, so 3 times 3 equals 9, so 9 is a square, and the square root of 9 is 3. 3 was the number that was multiplied by itself, and 9 is the square. So if I want to know what the square root of the number is, I say, well, what was multiplied by itself? That's the square root, okay? So it's not quite division. It's kind of similar to division, but it's a very kind of special way of breaking down numbers. It has to be a number times itself in order to be a square and a square root. So if a number is not a perfect square, which we have this example right here, square root of 27, so 27 can be broken into 9 and 3. And I want to try to break it into numbers that I know are squares. Well, we just looked at that, right? 9 is a square. And I know that the square root of 9 is 3, right? We just went through all that. So I can take the square root of 9 and I get 3. Well, this other 3 that was there, because it's 9 times 3, remember, we didn't just have 9. 9 times 3 got me 27. Well, that gets left behind. The other 3 stays under the square root sign because it doesn't have a square root. If you actually did the square root of 3, you'd get a funky decimal, and Alex isn't asking us to do that. So if you can't take a perfect square root, you leave it under the square root sign. All right, let's try this one with 8 u to the 14th. And again, there's no number here, so I know it's a square. Okay, I can't take the square root of 8 because remember, it's not 8 divided by 2. That's not what a square root is. I need a number times itself. Okay, so 8 I can break into 4 and 2. 4 times 2 is 8. 4 is a square, 2 is not. Okay, 14u can be broken into 7 groups of u squared. So when I'm dealing with a variable, I want to break it into the group of what I'm looking for. So if it's a square root, I'm looking for 2's. If it was a cube root, I'd be looking for groups of 3. If it were a fourth root, I'd be looking for groups of 4. Okay, so I want to break it into squares. So it can evenly be divided into 7 groups. Okay, so 4 has a square root of 2 from 8. And then u squared has a square root of u. Remember, I have 7 of those, right? So we're going to have to put the 7 back on here because I can do this one 7 times. So I have 2, that's the square root of 4, u to the 7th power, because remember, I was able to do this square root of u squared 7 different times. And then the square root of 2, well, that got left over because remember, we had 4 times 2 is 8. Okay, so it's just about breaking it apart. What numbers can I take a square root of? All right, if we keep moving on this one. So radical numbers can be multiplied. We group the coefficients and the radicals to multiply. So if possible, afterward, then we can take the square root of a radical number. So this one, 4 is the only coefficient. Remember, that's the number out in front. So this one has a 4. This one technically has a 1. So 4 is the only one. So now we're going to focus on 20 times 98. So 20 and 98 are both radicals. They can be broken down first or multiplied and then broken down. That's totally up to you. It's a preference. If you wanted to say 20 times 98 and then see if that has a square root, you could do that, or you could break it down from that large number. It is going to be a fairly large number. So you have 1,960, and you can try to see, can I take a square root of this? So this can be broken into 4, 49, and 10. So I picked numbers, again, 4 and 49. Those are squares. So if you have your squares memorized, this is going to make this much easier. Okay. 10 is not a square. It's going to kind of be a remainder. It's going to be left over. So the square root of 4 is, oh, what happened to the rest of my thing here? 2. And the square root of 49 is 7. So I'm going to have that 4 coefficient. Remember, that didn't go away. We just ignored it for a moment. And then I took the square root of 4 and I got 2. I took the square root of 49 and I got 7. And then that 10 on the end that I said is not a square just gets left underneath there. So I do need to go 4 times 2 times 7, and I get 56, square root 10. I could have also broken down 20 and 98, and then I could have multiplied the pieces back together. It's a preference on what you want to do there. So sometimes the larger numbers aren't necessarily easier because it's just more to break down. The smaller numbers sometimes are a little bit easier to break down. All right. So with this one, you can already see the 3 is the only coefficient again, so I only have 1. So if you had more than 1, you would definitely multiply those. But since we only have 3, we're going to leave it alone for a minute. And now we're going to look at 54 and 50 for our square roots. So you can break it down. Again, I'm just letting you know you can break it down, or you can multiply them together. So 50 times 54 gets me 2,700. And then I can break this number into 9, 100, and 3. Now, hopefully, if you were looking at this and you saw the 2 zeros, automatically, I hope you can recognize that, or divides, by 100, because there's 2 zeros. And then we have 27. Well, we broke that down earlier. 27 can divide into 9 and 3, right? So this one's not too hard to break down, but again, you do want to recognize those squares. So then 9 has the square root of 3, and 100 has the square root of 10. So we're going to bring that original coefficient back. We have our 3 that was out in front, our square root of 9, our square root of 10, and then that extra 3 that's left over, because remember that was part of the 2,700. I had that 3 on the end that does not have a square root. So now we're going to go 3 times 3 times 10, and we get 90 with a square root of 3. So this is just about simplifying as much as you can with a square root kind of left over there. So, simplifying square roots. I hope this helped, and I will see you in the next video.